Yes, Bhaskar Sharma. Welcome to online classes. Yesterday, we have discussed about transverse waves and longitudinal wave. Today, we will start the lesson from that. What is wave? We have discussed on different types of waves. Classification of waves also discussed. And also, we have discussed elaborately about the classification of waves. And finally, mechanical waves we have taken. From that, mechanical waves, we are having transverse and longitudinal waves. Let us start our lesson today, the difference between transverse and longitudinal wave. Okay, now a wave, transverse wave, according to yesterday's definitions we have considered, the main difference between longitudinal and transverse wave is the particle vibration. So the main difference, first difference what you have taken in this table, you can see transverse wave and longitudinal wave here in this table, in this PPT. First one, particles of a medium vibrate in perpendicular to the direction of wave propagation. Particles of medium vibrate perpendicular to wave propagation, that is one. And second one, particles of the medium vibrate here in the longitudinal wave side, particles of wave vibrate parallel to the direction of wave propagation. And second difference we are telling about examples. Waves in a stretched string. Waves in a stretched string. And here under longitudinal wave, sound waves in air. Generally we can take in air, compression and rarefaction takes place. That's why that is the third difference between these two. Third one, crest and troughs forms alternatively under transverse wave side, and under longitudinal wave side, compressions and rarefactions form alternatively. And finally, these waves exhibit the property of polarization. This is a special property exhibited by these light waves. Light waves are treated, that's why generally electromagnetic waves, all these are represented this property of polarization. So we can do in the further next chapters, we can study about this polarization. But in case of these longitudinal waves, there is no possibility to exhibit the property of polarization. Actually, the polarization means they have to take two perpendicular and parallel directions. Two directions the wave has to travel. One of the direction of the wave should be stopped. That is polarization. When sometimes the waves traveling in particular medium, the polarization property takes place. So in general, whenever we are asked to distinguish between differences between transverse wave and longitudinal waves, we have to write four important differences, that is particles vibration and examples and the names according to particle vibration. In transverse wave, crest and troughs forms, and in longitudinal waves you can see compressions and rarefactions. And finally the polarization point also we have to write. So this is actually about the transverse waves. Mechanical waves differences we have completed. Now coming to the next one, that is wave equation. Today we are going to see wave equation. What is a wave equation? The displacement of wave, that is represented by y as a function of x particle, position of the particle x and time t. While you are considering transverse wave, you can easily understand this. So the wave equation is represented as sine function as y x t. X t means that is x is position and t is time. At time t, that is represented as a sine kx minus omega t plus pi. Here the words, the letters what indicating a is amplitude, k is angular wave number, omega is angular frequency, and phi is initial phase. This we have to see this parameters clearly in this diagram. If you see this amplitude, while I am zooming this, okay, can you see amplitude? What is amplitude? The maximum displacement of the particle in this wave. This is in the x direction, the wave is moving, and in y direction, you can see amplitude A. Okay, now another parameter of any wave, the period. The period means this is also known as time period. The time period means the time taken for one oscillation. So one wave is formed, how much time it takes? That is called time period. This is represented by T. Time period units. SI units also we can see amplitude. SI unit is meters, and period or time period, capital T, is represented by capital T. The units are, this is also time, that's why units are seconds. And next parameter is whenever a wave is formed, generally we will talk about frequency. What is frequency? Number of oscillations or number of waves, we can tell. The number of oscillations per a point on a wave in 1 unit of time. In 1 unit of time, how many number of waves are formed? That is called frequency. So frequency and time period, both these two, how these two are interrelated, we can see in this formula. Frequency is 1 by T. And here in the formula of wave equation, omega T is there. Kx minus omega T. What about omega? The omega is angular frequency. Angular frequency means that is represented as omega. This is also known as angular velocity. Radians per a point on the wave in unit direction. So this can be represented as equation. As per equation, it is 2 pi f. Why we are writing 2 pi f? For a frequency, what is frequency? Number of oscillations per unit time. So unit time, how many, what is its frequency? That frequency is represented as f. Whenever a wave is formed in that frequency of time means that is unit time, it can form 2 pi angle. For each 2 pi angle, waves are formed. 2 pi angle is completed. As per the equation, y is equal to a sin kx minus omega t plus phi. Totally, what are the parameters are explained here. All these, while you are observing these parameters, you have to understand this is a sine function. When it is a sine function, sine functions varies the values maximum from 0 to 2 pi. Therefore, while you are writing these angles 0 to 2 pi values, a sine, whatever the values kx minus omega t plus phi, totally different. We can explain the position of the all these waves which they are presenting. So here, amplitude, the definitions and units, and also how to find those values we have to understand. Not only this, some more are there, some parameters. That is, wavelength is another parameter is there. That is not shown here. The wavelength is represented by lambda. What is the wavelength? Let us see the distance between two consecutive points of same phase. That is lambda. So distance between two consecutive points in the same sequence in this diagram, amplitude, here 2 points are shown, and consecutive amplitude point shown here, that points, while these 2 points distance is lambda, wavelength. So while consecutive points are there, that is lambda. So wavelength you can take formula, lambda is from here to here, 2 consecutive points of same phase points makes an angle of 2 pi. Therefore, the wavelength lambda is 2 pi by k. We have to take 2 pi by k, where k is wave number. Again, from the same formula, what is wave number? Here, we have to see that wave number in the formula equation kx. That k is called wave number. That is also called angular wave number. Angular wave number means it is the ratio. Only you have to remember it is the ratio of 2 pi and lambda. 2 pi and lambda. The ratio of 2 pi lambda means that units of k, angular wave number, 2 pi is taken as radians, lambda is represented as meters. Radian per meter is the angular wave number, SI units. So whenever a wave is written, the wave is represented in the form of yxt, that is equal to a sine kx minus omega t plus phi. All the parameters we should know. K is, in this formula, k is angular wave number, that is represented by k, which is equal to 2 pi by lambda, and x is position of the particle, and omega is angular frequency, which is represented by 2 pi by t. Angular frequency omega is 2 pi by t. Units are radian per seconds, and amplitude is meters, and wavelength. Wavelength means the distance between two consecutive points of same phase. Therefore, lambda 2 pi by k. Units are radian. Here, wavelength is represented in terms of meters. So this is about the parameters of a wave equation. These are all parameters of wave equation. Now coming to this velocity of wave, the important thing what we are going to see today class, whenever a wave velocity is considered, how to find out velocity. What is velocity in general meaning? The distance traveled in unit second is called distance. Distance by time is called velocity. In case of waves also, in the same manner we can calculate a wave travels a distance in unit time. How much distance it can travel in unit time, that we have to taken as velocity of wave. Whatever the wave here, wave means whether it is transverse wave or longitudinal wave, whatever it may be, you have to write velocity as v is equal to lambda by t. How we are writing this lambda by t means during time period t, it makes only one oscillation. This one oscillation distance, while you are horizontally we are measuring the sine curve, the distance is called wavelength. Therefore, lambda is wavelength, and by time means by t. Again, v is equal to lambda by t. In this 1 by t is called frequency. So v is equal to nu lambda also you can write. Frequency into lambda also you can write. Therefore, hence v is equal to nu lambda is velocity of wave. Whatever the wave it is, whether it is transverse wave or longitudinal wave or whatever the wave it is, the formula you can use, velocity of wave is equal to nu lambda, or if nu is frequency here, both are seems to be same, you don't confuse. This is called nu. First one is v, velocity, and the frequency into wavelength. The product of frequency and wavelength gives the velocity of wave. Otherwise, if frequency is not given, then we have to take lambda by t, wavelength by time period. Here t means time period. Now, speed of transverse wave in a stretched string. How to, this is general formula for wave equation, velocity of v is equal to nu lambda, lambda by t. This equation is general equation. For example, here we are going to see speed of transverse wave in a stretched wire. A string is taken while it is stretched. The important thing is stretched string. It is not only string. Stretched string means we have to apply some force both the ends. Then only it should be a stretched. While you are applying force, both the ends of the wire, a metal wire you have to consider, then it becomes stretched. Force is applied, then only we can produce transverse waves in the stretched string. That's why while you are applying the force, that force is called tension. Tensional force, T, it is represented by tensional force. So first you have to stretch the string by the application of T. T means tensional force. And next, linear density. The stretching of the wire depends on its some parameters, some important things, that it's elastic property of the medium. One may ask, if there is no elastic property, is it possible to send transverse waves? Another question arises. Definitely it is not possible. Definitely it is not possible. Whenever there is mechanical waves, we have already yesterday we have discussed about mechanical waves. The particles have to be vibrate. Where is the particles and how they are vibrating? The names are different according to that. Longitudinal wave and transverse wave we have discussed. Okay, so particles are coming close in compressions and rarefactions takes place in case of air particles. Generally it is possible. As it is a solid, there is no possibility of coming close and moving away. We can take this linear changes of these particles may be negligible. In that cases, we can take transverse waves. So particles move up and down and again coming to its mean position. While this process takes place, while application of force, the particles will have to vibrate any one of these directions, whether parallel or perpendicular. And again, this particles vibrating means, again coming to its position means, it has the property of elasticity. So the speed of the wave depends on two factors. One is elastic properties. That is first one, that is tension force. How much force you are applying, and also while you are applying the force, then what about it? Linear density. Linear density means density per unit length. We have to consider in case of solids, the linear density have to be considered. Therefore, it depends on two factors. The velocity of wave in transverse wave depends on these two factors. One is tensional force. Second one is linear density. So how to derive this relation in stretched thing? What is the velocity of wave? How to derive means we have to take according to dimensional formula. It is easy to derive. So we are showing here V proportional to T power A and mu power B. First, we are writing like this. V is proportional to two factors. That's why V is proportional to how many times the tensional force? A times. So T power A. And how many times for linear density? Mu power B. Therefore, V is equal to remove this proportionality, we have to take proportionality constant, that is K T power A mu power B. Now we are writing the dimensional formula of V, that is m power 0, L power 1, T power minus 1. That is velocity in LHS side, velocity dimensional formula we are writing. And K, that is a constant. So we are not taking any dimensional formulas for constants. So taking T means tensional force. Therefore, I am taking here force dimensional formula. We can take force dimensional formula m power 1, L power 1, T power minus 2. F is equal to ma. According to that, I am writing m. A means acceleration. Therefore, L power 1, T power minus 2 whole power A times it is. And also mu. What is mu? Linear density, mass by length. Generally, density is mass per volume. Here, linear density means per unit length. Generally, we should not consider here volume of the string. Instead of volume, mass by length we have taken. That's why it is called linear density, mass by length. Therefore, m power 1, L power minus 1, whole power B. So, while again writing m power 0, L power 1, T power minus 1, m power A plus B, L power A minus B, T power, we have to, yes, T power minus 2A. And comparing the powers, we can get A is equal to half and B is equal to minus half. While substituting these values, the proportionality constant is proved to be 1. It is not derived from this dimensional formula. Whenever proportionally constants, we have to take another one. That V is square root t 1 into t power half into mu power minus half. What does it mean? V is equal to square root, you can write square root of t by mu, you can write. Finally, the velocity of the wave, when in a stretched wave, you have to consider as square root of t by mu. Similarly, this is about velocity of wave and equation. Here you should remember, in this class we are going to see different parameters of wave equations. First we have discussed, and also before going to that, we have already completed yesterday's transverse and longitudinal wave differences. We have discussed. After discussing differences, we are going to see progressive wave equation. Wave equation is taken as, that is most important, y is equal to a sine kx minus omega t plus phi. In that, each one, a is amplitude. The amplitude means the maximum displacement of the particle in a wave motion from its mean position. That we have to write. And also amplitude units we have considered. Units are meters. And next, coming to next parameter k. K is angular wave number. K is angular wave number. Only it gives the ratio of angular wave number, gives the ratio of 2 pi and lambda. 2 pi and its wavelength. Whenever a wave is considered, it has wave length lambda. So 2 pi by lambda, and its units we have discussed, radian per meter. And also next parameter is the angular frequency. It is represented by omega. Omega is equal to 2 pi by t, angle subtended by the particle in units time. Actually, that is the definition of angular frequency. Angle subtended by the particle in unit time. In t time, it completes, capital T time, it completes 2 pi. One oscillation it completes. Whenever it is one oscillation, which is equal to 2 pi radians. We have to remember, one oscillation is equal to 2 pi radians. And also that is equal to time taken, that is also equal to capital T. So we have to remember these, capital T. So angular frequency means angle by time. Unit time, how much time it takes? 2 pi by t. So units of angular frequency, radian per second. 2 pi is the radians. Units we have to take. Time is t. So 2 pi by t. That is angular frequency, omega. Here, last one, kx minus omega t plus phi. This is most important. Sometimes it may be asked also, what is the initial phase? Phi means initial phase in the equation. X is equal to 0. So what does it mean x is equal to 0? The particle is at the beginning. In the axis we are considered, t is equal to 0. Time small t. In the equation, time t is also there. If t is equal to 0, what happens? Both these two, x is equal to 0, t is equal to 0, then we can consider that initial phase. That is phi. Understand? Both these two, x0, t0. So generally, we can neglect this one. Then equation becomes a sine ks minus omega t. If the particle starts from the origin, then you can consider directly from this also. So these are important things we have to consider. Whenever there is a particle started from origin, means there is no need to write phi. So wave equation is y is equal to a sine kx minus omega t. That we have learned now. And coming to next one, what is velocity of wave? Velocity of wave is taken in case of general equation is v is equal to nu lambda. Whenever a wave is considered, wave velocity is considered, we have to take nu lambda or lambda by t. Both these two are same. 1 by t is equal to frequency. That's why 1 by t you can write, that 1 by t is replaced by frequency. So you can write v is equal to nu lambda or lambda by t. That is general equation. Now coming to this next topic we have discussed today, that is velocity of wave in a transverse, velocity of the transverse wave in a stretched string. That is most important from here. Here, whenever it is stretched one, it depends, velocity of the wave in the stretched wire depends on two factors. One is tensional force, another is its linear density. Both these two, how they are depending, how we are calculated this equation, derived this equation means by the help of dimensional formula we have derived. Dimensional formula while writing for T and mu. T means tensional force, force dimensional formula we have written, and also mu, linear density, means m L minus 1. Mass by length, linear density means mass by length you have to take. So while substituting those values and according to dimensional formula, how it is depending, V is equal to K T power A and mu power B we have taken, and also A, B values, A and B values also by comparing the powers of these dimensional dimensions of length and time and all these, we can find out A is 1 by 2 and B is minus half. A and B we are getting. Substituting these plus half and minus half in the above taken equation, then we can get V is square root of T by mu. In this figure, you should remember this square root is related to both T and mu. Here it seems to be only root T, but actually it should be root square root of both of these fraction, total fraction T by mu and square root we have to write. This is a lesson which we have learned today. And speed of the only transverse wave we have discussed. If you are considered it is longitudinal wave, what is it? In solids, generally we have to consider longitudinal waves also. Speed of the sound wave is considered. How you can calculate? Means speed of the longitudinal wave, how you can take in a bar, how you can take that V. V is square root of y by rho. We have to write instead of T by mu. First you should remember what is T and what is mu. Based on this T, instead of T, it is a stretched wire. T is, we have discussed it, a tensional force. If it is in air or solid bar, some longitudinal waves are formed. Then how you can calculate V? What are the parameters? What are the factors affecting this velocity means? That is bulk modulus of the medium. In solids, we have to consider bulk modulus. So elastic properties are considered instead of the bulk modulus. If it is a solid bar, we have to take Young's modulus instead of T. And instead of mu, that is linear density, we have taken as rho. Root y by rho is the velocity is considered. Okay, longitudinal wave is considered in gases. Generally, if it is ideal gas, then V is equal to this square root P by rho we have to write. Just only two parameters we have to write. You remember, this is basic equation. And if it is a longitudinal wave, we can take V is equal to square root of P by rho, where P is pressure. Density is related to pressure. So Y is replaced by P. So Newton derived velocity of sound by using this formula. V is equal to square root of P by rho, where P is pressure, rho is its density. While calculating Newton, the velocity of sound in air is, as he has calculated, 280 meters per second. 280 meters per second. And finally, actual experimental value, that is not 280, that is 330 meters per second. Instead of 280, experimental value 330. So there is a difference of 15% of difference between calculated value according to theory given by Newton, V is equal to root P by rho, and experiments conducted, experimental value is more than this theoretical value. The difference is there. So another scientist, Laplace, changed this equation. there is a small change. According to Newton, this process, the velocity of sound in air is isothermal process. Isothermal process means the temperature should not change. Why we have taken prior here? Actually, whenever energy is produced, prior factor comes into act. Why? Because while prior is particles are coming close, the prior increases. Compression increased prior. Rarefactions, particles move away. In a longitudinal waves in air, compressions, rarefactions takes place. While compression takes place, prior increases. Rarefaction takes place, prior decreases. Therefore, the pressure changes in air is isothermal process according to Newton. According to Newton, the pressure changing only at constant temperature. Isothermal means the temperature of the medium does not change. The temperature does not change while wave is propagating through the particle medium. Okay, let us finish now. So, but actually that is not correct. Laplace say that this is not correct. This is not isothermal. It is adiabatic process. What is adiabatic process? Adiabatic process means the temperature changes. So in that case, PV power gamma is equal to constant. According to that, the gamma is ratio of specific. It's next we can next class we will discuss this Newton-Laplace equation and also principle of superimposition of waves. So V is equal to gamma P by rho. Instead of P, Laplace characterizes the equation. Again, in the next class we will discuss that, and also principle of superimposition of waves, and also stationary waves, how they are produced in strings. Tomorrow we can, next class we can discuss about those also. Thank you very much. Thank you all.